Dear viewers, in this class we are going to learn the stereochemistry of SN2 and SN1 reactions. Before going into this topic, you should know how to assign the absolute configuration of any chiral molecule. If you are not conversant or not sure how to assign the absolute configuration of the chiral molecule, I already made a video lecture on a trick how to assign absolute configuration that can be done in maximum 10 seconds that I given in the description link. Please go through it, and it is very simple. If you are able to understand how to assign the absolute configuration, then it is very easy to understand the stereochemistry of SN2 and SN1 reactions. Okay, now let us go into the topic of the stereochemistry of SN2 reaction. So what will happen if a SN2 reaction takes place in the chiral molecule? Before going into that, let's see some analogy. You see, so this is an umbrella, and if the wind is striking, so what is happening? This umbrella is getting inverted. So that means the inversion of the umbrella took place. That means that umbrella turned inside out because the wind is passing through in this direction. The same analogy. If the SN2 reaction takes place at the chiral center, as we know, the nucleophile always attack from the back side. So that is opposite to the leaving group. So what happens when it attacks? So this nucleophile get attached here, and this is turned other side. So if you learned the absolute configuration, then it is very easy. You see, in the starting material, the absolute configuration is S configuration. After the nucleophile attacks the chiral center, the absolute configuration is become R. That means that configuration is getting changed or inverted. So this is called as inversion of absolute configuration. So that means the SN2 reaction always gives inversion of configuration. So this is the outcome of the nucleophilic attack in the SN2 reaction at the chiral center. Okay, it gives inversion of configuration. Now let's see what will happen if the nucleophile attacks at the chiral center and the reaction is taking place through SN1 reaction mechanism. Now this is the example we have took for the SN1 reaction. As we know, the SN1 reaction easily occurs at the tertiary alkyl halide. So this is a tertiary alkyl halide, and you see this carbon is chiral center. Okay, so this is connected to 4 different groups. This is the chiral center. As we know, the reaction mechanism, the first step is the formation of carbocation. So this is the carbocation is formed. So this is an empty p orbital. You see this is a green color lobe. So this is an empty p orbital. After the carbocation is formed, the nucleophile will attack. Now there are two options. The nucleophile can attack from the top side or from the bottom side. If it is attacked from the top side, you see you are getting this kind of molecule, and when you are attacking this this carbocation from the bottom side. So you are getting this type of compound. Now just closely observe the absolute configuration. You see, the starting material is S configuration from the starting material. When it is attacking at the top view, so you are getting the S configuration. When this carbocation, which is the planar in nature, so the nucleophile can attack from the bottom also. So you are getting this type of configuration. Here the absolute configuration is getting R. So the possibilities are, this will form 50% and this will form 50%. So this is having S configuration and this will have the R configuration. So that means this both will have the opposite optical rotation, that is in equal in mixture. These are 50-50%. That means the mixture is in the equal amount. So what will happen? One of this chiral center, this may be either plus or minus. If it is this plus, then this should be a minus, or vice versa. If it is a minus, then this should be a plus, vice versa. So but the amounts are in equal amounts. That's why the optical rotation will get cancelled. So the SN1 reaction at the chiral center takes place. So the outcome is the racemic mixture. So the racemic mixture is always optically inactive. So this is the outcome of the SN1 reaction, the stereochemical outcome of the SN1 reaction. For the SN2, inversion, and SN1 you are getting optically inactive because the racemic mixture is formed in the equal amounts. That's all. Thank you.